Good afternoon, everyone, and welcome to the Hydrogen and Fuel Cells Europe here at the Hannover Messe 2023. We're here at the technical forum where we dive into all of the tiny little details of the hydrogen sector. Please have a seat, have a drink. There's two lovely hostesses that can help you to any drink you like. So up next, we'll be talking about something very important, about scalable production of energy storage system. Here from Fraunhofer IPT, Head of Business Unit Energy Storage, please welcome to the stage Clemens Müller. Welcome.
Welcome.
Thank you.
Hi, Joris. Thank you very much for this kind introduction. My name is Clemens Müller, Head of the Business Unit Energy Storage at Fraunhofer IPT. We are Fraunhofer Institute for Production Technology. So today I want to talk about the scalable production of different energy storage systems. And of course, as we are on the Hannover Messe, we will be talking about hydrogen systems. Hydrogen as such has a huge potential for the decarbonization of our society and industry. When we want to reach the net zero scenario, then there will be a demand for hydrogen globally in 2030 of more than 200 gigawatt. And the question will be, how can this hydrogen be produced? When we have a look on the left side, we see how different production technologies for the hydrogen can contribute to this overall aim. And we see on the blue bars that the electrolysis plays a major role. Why is that the case? Because electrolysis is the technology to produce green hydrogen, and that's the kind of hydrogen we need. So for 2030, we see that there is quite a lot of green hydrogen we need to produce. And what we also can see is that today there is almost non-green hydrogen produced by electrolysis. It's a very, very small amount which is produced with the electrolysis. So we see a clear need to ramp up the production technology for the hydrogen systems and for the electrolyzers. On the right side, we see the European perspective. In 2030, Europe wants to produce 40 gigawatt of green hydrogen, and you see that also a lot of the member states of the European Union have already committed to do their to participate in that production. Now, as I said, the electrolyzer market has to grow rapidly in order to cover all that hydrogen demand that we have and that we face in the future. On the one hand, we see a lot of advancements, a lot of research is going on, a lot of development is going on. We have developments in the material sector, we have developments on system level, and we have developments in the production technology. On the other hand, there are still some barriers that have to be overcome. One is, for example, the missing hydrogen infrastructure. Another barrier, which refers to the overall system, is the public awareness. How or why do we want to use hydrogen when the efficiency of the systems is that low compared to, for example, battery systems? And we still have pretty high costs, and production is one of the main factors why the costs are still that high. Let's look into a quantification of the potential of the cost reduction with the improvement of the manufacturing. This is the very core of our work at Fraunhofer IPT, that we look into the production. How can production technologies be optimized? How can the right technologies be chosen in order to optimize the efficiency and the economic issue of the production? So what we see in general is that the more systems we produce, the lower the costs for the single systems. That's nothing which surprises us, but still the technology has to be developed how these numbers of electrolyzers can be produced at all. And that's basically the same story for the fuel cells on the side of the hydrogen utilization. You also have to produce numbers of fuel cells which go into the millions, and right now production technology is just not far enough developed. So what we see is that the technological development of the systems can reach to to a reduction in the costs of round about 29%. And on the other hand, scaling up the numbers of the systems we produce will lead to a reduction of the manufacturing costs by 75%. So that's a huge leverage we have to use in order to make the hydrogen technology economically competitive. On this basis, what we are doing at Fraunhofer, not just at Fraunhofer IPT, but also in cooperation with other Fraunhofer institutes, is we are working on we call it in German the Referenzfabrik. The English term would be something like reference manufacturing plant. So what do? First of all, we build up infrastructure for the production of single components in high volume. We do it in a decentralized way. So in some Fraunhofer institutes, we build up manufacturing plants for bipolar plates. In other Fraunhofer institutes, we build up manufacturing plants for, let's say, MEA components, or for example, for a GDL or for a PTL. And we want to use this production infrastructure for the cooperation with industry. The research that we are doing at Fraunhofer is always with the aim to transfer the results into the industrial applications. And that's why we also have a booth here at Fraunhofer, at Hannover Messe, in order to present what we have researched and developed so far, and also in order to offer you connection points to the research results. That's what we want, to transfer this knowledge into the industrial application. So let's have a closer look into the Referenzfabrik. What do we do here? The reference manufacturing plant offers several fields of action. One field of action is the technology kit. We, for example, do benchmarkings. When a customer comes to us and wants to produce, let's say, bipolar plates, metallic plates or compound plates, doesn't matter, then we can offer to do different benchmarkings, have a look into various production technologies. We do that on a theoretical level, but we also do it with a prototypic production that we have already built up and that we are still about to further build up. Based on this benchmark, we develop a technology kit which gives indications which technology is best for the single designs and for the individual request of the customers. That's the first thing in the technology kit. Then we have the second field of action named services. What do we do here? I said that we built up the production lines decentralized. So at our institutes, we produce the MEA, for example. Another institute produces the bipolar plate. And in the end, the customer wants to have one overall manufacturing plant where all the different components are produced. So we bring all these single decentralized production plants together in a digital way and have one digitally connected production line where all the components can be manufactured and where in a digital way the production can be developed, can be commissioned, for example, and where different interactions can be analyzed. Then as a third field of action, we have the platform. So the reference manufacturing plant wants to be a platform for networking, for connecting, for offering products, and for finding partners and suppliers. So this is the third big field of action that we have in the reference manufacturing plant. What are the very targets of our work here? I named it in the beginning of my speech. We have to reduce the costs. This is key to enabling hydrogen systems and to bringing them into the market. Second of all, speed plays a major role and corresponds very clearly to the production costs. What we see on the electrolyzer side of the hydrogen economy is that we need a certain flexibility. The designs of the electrolyzer systems that are out on the market are very different, and we try to build up the manufacturing in a very flexible way so that a single production line is able to produce a large number of different variations of a single component. That helps to reduce the capex costs and is, at the end, key for an economic electrolyzer production. On these two pictures, you can see two of these production lines I was talking about. Both of them are placed at Fraunhofer IPT in Aachen, and we are looking onto two different production machines for metallic bipolar plates. The left one is a rather classical approach. This is the discontinuous forming in a progressive die tool. On the right side, you see a rather innovative approach, and this is the continuous roll-to-roll forming. So we are operating both of the machines, of the production lines at our institute, and that helps us to be able to support our customers in the right way. When they have a design and a certain production scenario, we are able to do a benchmarking theoretically, but also experimentally on a prototypic basis. The same is true for the MEA production. Here you see a short wrap-up of the different stages of how an MEA component is produced. You see the single layers, and we have tons of questions about how to position different layers on top of each other, how to align them in the right position, how to handle them automatically. So these are the questions that we deal with on the side of the MEA production. And yeah, I hope to give you an interesting insight into our work with my little presentation today. This is already my last slide, so thanks a lot for your attention, and I would be happy to welcome you at our booth. Thank you.
Thank you very much for your presentation, Clemens. Are there any questions from the audience? Please raise your hand if you have one. So, the energy transition, we need to go really fast, right? So, in all these goals that are set by the European Union, by 2030, we need to have, I think, 40 gigawatts of electrolyzers here and 40 outside of Europe. How do you think the research that you're doing at Fraunhofer IPT is helping to accelerate that energy transition?
At Fraunhofer IPT, we understand ourselves as enablers. Our business model is not to position ourselves as a supplier of components. We want to position ourselves as an enabler for industry partners. We think that, especially in Europe and in Germany, we already have a lot of companies with a portfolio which fits very well into the hydrogen economy. And our role is to make use of that potential and enable the companies to participate in the hydrogen economy.
Right, so give them the skills to basically to scale up their production, to increase their production,
exactly,
such that we can hopefully reach all of those climate goals.
That's exactly the target, and what we built up in terms of production machinery is also thought as a certain orientation where the industry companies can connect to and see how we do it and then scale it up in a bigger number.
Thank you. So if you have any more questions for Clemens, please visit them at their booth. What was the number again?
13, I think. E13.
E13. E9.
E9, sorry.
E9, sorry, that's
it was on the last, well, E9 is the right.
It's tough to remember these stand numbers, right? All right. Thank you very much.
Thank you.